All right, so in this problem we have 10 disks. Each of them is labeled with a unique number 1 through 10, which means no repetition or anything. And if we randomly select 4 disks, what are the odds that the range is 7? So I think the first thing to get with this one is, okay, so what does it mean if the range is 7? Well, there are 3 different ways that this could happen. We get one disk which has a 1 on it, and another disk which has an 8 on it, right? So the range is 7. And then the other 2 disks are in between these. So I can't like pick 9 or 10, because they said the range is exactly 7. So this is one possibility. Another possibility is obviously 2 through 9 or 3 through 10. So these are 3 different ways that we could get a range of 7 with these 4 disks. Now, a lot of probability problems, when you have something like this, the easiest way to do it is using a combinatorics approach. So probability basically is number of desired outcomes over total outcomes, right? So we can treat each of these like a separate combinatorics problem. Let's figure out the total number of outcomes possible if I select 4 of these disks. And then let's figure out for the top separately the number of desired outcomes, okay? So let's do the bottom part first because that seems easier. So what are the total outcomes? Meaning nothing about the range, just I'm going to pick 4 disks. So essentially it's going to be something like this. This is the denominator down here. So if I'm going to select 4 disks, then I'm going to have you can do a slot diagram for this. Okay, there's 2 ways to do this. So each of these represents one of the disks. So I can say there's 10 possibilities for the first disk, 9 for the second, 8 for the third, 7 for the fourth. And then since order doesn't matter, then I need to divide by the number of arrangements possible with 4 disks, which is 4 factorial, okay? Or another way to write this, some people like this more, 10 factorial over the number that you selected, 4 factorial, times the number you didn't select, 6 factorial. You'll see that these 2 actually are the same thing. I personally like this one more because I feel like I know what's happening, but this one's kind of easy to memorize. All right, so anyway, this should be the denominator. Now, figuring out the number of desired outcomes, it's a little tougher, I think, but still not too bad. So let's do this. Imagine we assume that you got disk 1 and disk 8. Okay? What I'm going to do is figure out how many different combinations of disks could we get if you had disk 1 and disk 8. So that part is just assumed. So how many disks do we have left? 2, right? So we can then basically do a separate problem, sort of like this one, and say, look, if you have 2 disks, right, then how many different groups of 2 disks can you select, assuming that they're in between 1 and 8, which means, how many do I have? I have 6, right? 2, 3, 4, 5, 6, 7. So that's 6 different possibilities. So it's similar to this. I'll say, all right, so there's 6 for the first slot, 5 for the second slot, and then I'll divide by 2 factorial because of the number of ways to arrange them. And this should represent the number of groups of disks that I can get, 4 disks, that have a 1 and an 8, and then some other numbers in between 1 and 8. Cool? My cat is rubbing my tripod. Stop it. Stop. So anyway, now this is just for the 1 through 8, right? But since we also have 2 other ways that this could happen, then I want to multiply this by 3. So I'm just going to put a 3 on the outside. Okay? Now, these are sort of separate, but this should be the numerator, that's the denominator, and if we wind up like canceling things out, then hopefully things will sort out the way we want. So let's just cancel stuff. What have I got? I've got a 2 here and a 6 here, so I'll cancel the 2 and the 6, and I'll wind up with a 3. So there are 15 different ways to have a 1 and an 8, and then a couple of numbers in between, but since that's the exact same number as the 2 and the 9 and the 3 and the 10, then I should just multiply that by 3, right? So I wind up in the numerator is 3 times 3 times 5. Meanwhile, the denominator, let's just cancel out what we can here, okay? So the 4 factorial is actually 4, 3, 2, and 1, okay? 1 doesn't matter. So let's just cancel as fast as we can to sort of sort things out. 4 and a 2 makes 8, right? So I can cancel those out and cancel the 8. A 3 should cancel out with a 9. So cancel that 3 and the 9, put a 3 out front here. Okay, so this is the denominator. Here's the numerator. Let's see what else we can cancel. Here's a 3, there's a 3. I got a 5 and a 10 here, so I can cancel the 5 and the 10. I'm left with a 2. I can't cancel anything else left, so what have I got left? 3 over 14. And that should be the answer.